Okay, so this is a lesson on how to solve systems of linear equalities using the substitution and elimination methods. This lesson is meant to not be a first lesson on this. This is meant to be an Algebra 2 lesson for students who have seen this in Algebra 1 but need a refresher before moving on to more difficult topics. The first thing we want to remember about a system of linear equations is when we solve that system, the two equations are going to intersect at some point, hopefully. That's really the number one situation we're going to be looking at. 99% of our lines are going to cross. And the reason they're going to cross is that the slopes are going to be different. Every once in a while, we will have lines that never intersect. And as we solve those, we might get a statement that's never true, like 0 equals 3. And it's because the lines are parallel. They have the same slopes, so they don't share any points. Even rarer is the situation where we have two lines where one line is exactly the same as the other line, and when we go to solve them, we'll get a statement that's always true, like 4 equals 4. But like I said, 99.9% of our systems are going to actually cross, and we are looking for that point on both lines because that is our solution. That point makes both lines true. So here we go. Everybody write down number 1. The first thing we're going to do is solve some equations by substitution. When you think about substitution, I always like to give the example as if you go to a restaurant and you substitute something on your meal, one food item comes off and a different food item comes on. So we can see number 1 says x equals negative 2y. That means that x can be substituted equally for negative 2y. So we're going to go to the second equation where it says 3x plus 4y equals 4, and we're going to substitute x for negative 2y. This process is going to feel a lot like the composition of functions because it's like f of g of x, the x comes out and something else goes in. So in this case, instead of 3x, we're now going to have 3 times negative 2y. We've substituted. Now we're just going to go ahead, multiply, combine like terms, divide, and we get the y-coordinate of our intersection point to be negative 2. Now, to find the x-coordinate of our intersection point, we're going to pick up that negative 2 and put it in either equation. But because I want to be really efficient, I'm going to go into this x equals equation because it's not going to require me to do any algebra. I'm just going to have to evaluate. Because if I say x equals negative 2 times y, which is negative 2, I get x equals 4, and my solution is the ordered pair 4, negative 2. That's where the lines cross. Now, if I want to check my solution, I'm going to plug 4, negative 2 into the equation I did not just use. So I just used the top equation, so I'll check in the bottom equation, just to make sure that this point is on the second line. I know it's on the first line because that's how I got it, is I plugged in negative 2 and I found out what x is. So let's see. 3 times 4, which is 12, plus 4 times negative 2, which is negative 8. Oh, guess what? That adds up to 4. Check. So we know that this solution is the point on both lines. Let's try number 2. Everyone go ahead and write down number 2. Alright, so number 2 says y equals negative 3x plus 14. That means we are allowed to substitute y for negative 3x plus 14 because they are equal. So I'm going to take negative 3x plus 14 and I'm going to substitute it. So instead of negative 3x minus 2y, positive 3x minus 2y, I'm going to have 3x minus 2 times negative 3x plus 14. Now I'm going to distribute the negative 2. I want to make sure I distribute negative 2 so it becomes negative 28. And I'm just going to solve. So I've got 9x minus 28 equals 17. Add 28. We get 9x equals 45. Oh, that's nice. So x equals 5. So I have the x-coordinate of the point. Now we need the y-coordinate of the point. I'm going to take the x and I'm going to go back to the original system. And again, I could put it here or I could put it here. But I want to be efficient, and this already says y equals. If I go into this equation, I won't have any algebra to do. I'll just have some evaluating. So I'm going to put it here. So we've got y equals negative 3x plus 14. So negative 15 plus 14 is negative 1. So the ordered pair is 5, negative 1. And I'm going to check it just because I want to make sure I'm doing it correctly. And again, the checking is optional, but it's always a good idea in a problem that's this long involved and probably worth a lot of points on a test to make sure your answer is actually correct. It's very, very easy to make an arithmetic mistake and not realize it because you have integers. Honestly, this is the second time I'm making this video because the first time I made it, I didn't check my solution and I was all the way over here and realized that I had brought down the 4 as a 2 and then written y equals negative 1 and I started all over. So it's definitely, and I realized that because I had checked this one and then I went back and checked the others. So it's probably a good idea to check. Minus 2. So I'm checking in the second equation again because I used the first equation to find my y value. You never want to use the same equation to check that you found the y value with because of course it's going to work. That's where you got the negative 1. We want to see, does this equal 17? So 15, this becomes, yep, we're good. It checks. Write down number 3, pause the video, and try that one on your own. Okay, so hopefully you realize that it was actually the second equation that was set equal to x or y. This one says x equals 3y plus 4. So we're going to circle the minus 4, and it's going to go to x. And we've got 3y minus 4 minus 2y equals negative 1. 3y minus 2y is 1y, minus 4 equals negative 1, y equals 3. Now we're going to take the 3, we're going to pick it up, we're going to put it right here, do a little evaluating. 3 times 3 minus 4, 9 minus 4 is 5. Our solution is 5, 3. It'll take me just 1 second to check. X minus 2y needs to equal negative 1, and I see it does because I've got 5 minus 6. Woohoo! So that's the substitution method of solving a linear system. Let's take a second and look at the elimination method. So everyone go ahead and write down to retitle, new title, solve linear systems with elimination. Some teachers call this combination. I call it elimination because you eliminate something. And write down number 1. Now, our goal with elimination, let me make some room here so I can put some notes in, move you guys down. So, when we are setting these up, our goal, oh, we cannot use Comic Sans anymore because it's grossing me out. There we go. Alright, so the goal is this. We need both equations to be in standard form. Remember, ax plus by equals c, equals the constants on the right side. We need, so I'll write that down. Ax plus by equals c. And we need the coefficients of, did I spell that right? I feel like I have too many C's. There we go. Of x or y to be the same number but opposite signs. So here's what I mean by that. If we had 5y and negative 5y, that would be, we would have met the goal. If we had negative 4y and positive 4y, that would meet our goal. If we had, I don't know, 10x and negative 10x, that would meet our goal. So we look at number 1, and they're all in standard form, so that's good. But we have a 1x and we have a 1y. So that's kind of an ideal situation, because when I'm looking to figure out how I can make these the same, ones are nice. Ones are like the chameleon. I could make this is already 5x, I could make the top equation negative 5x by multiplying the whole equation by negative 5. Here I've got negative 2y. It would be great if this was positive 2y. So I could multiply the whole equation by positive 2y. So we have a choice to make. Do we want to multiply the top equation by negative 5 to make it negative 5x? Or do we want to multiply by 2 to make it positive 2y? Take a second and think about what the most efficient method is going to be to make the least errors. If you picked multiplying by 2, that's what I would do. I would multiply everything here by 2, because if I can avoid negative numbers, I'm probably going to make less careless mistakes. So I'm going to multiply the whole first equation by 2. Here we go. 2x plus 2y equals negative 18. So there we go. And I'm going to recopy the first equation. 5x minus 2y equals 32. And the reason that some people call this combination is now we are going to combine these two equations. We are going to add straight down, combine them. So if I combine 2x and 5x, I'll get 7x. If I combine positive 2y and negative 2y, I get 0 y's. Hooray! They have eliminated. That's why it's called elimination also, because you combine and you eliminate. Alright, so negative 18 combined with 32 is 14. And quick little division here gives us x is 2. Now we're going to approach this the same way we approached the substitution problems. Once I get the first coordinate, I'm just going to solve back. Now, I am going to have to do a little algebra here, so we want to think, what would be more efficient? To go into the original first equation or the original second equation? Yeah, I picked the original first equation also because it's just 2 plus y equals negative 9. So y must be negative 11. So our ordered pair, we always want to write it as an ordered pair, is 2, negative 11. And if I want to check that really quick just to make sure I'm correct, let's see. I'm going to use the second equation because I used the first equation to solve. 5 times 2 is 10, plus 22 because negative 2, that's, 32. Check. I want you to write down number 2, and I want you to think about how we can multiply one or both equations so that one set of coefficients will be the same number but opposite signs. Okay, so we don't have any number 1s here, so that's kind of sad. We have a 3 and we have a 2 for the x's. We could multiply the first one by a 2 and the second one by a 3, and that would give me 2 6's, but I need one of them to be negative, so I should multiply one of them by a negative 6, or by a negative number. Over here, I've got a 6 and a 4. Now I can make these both 12 pretty easily. I could multiply this one by a 2 and this one by a 3, and that would give me negative 12 and positive 12. And because that doesn't make me have to use any negatives in my multiplication, and the less negatives the better, that's the method I'm going to go with. So again, the goal here, this is a negative 12 and this is a positive 12, they will eliminate. So 2 and 3. So here we go. 6x minus 12y equals negative 6. 6x plus 12y equals 90. Now if we add down, we get, now remember these don't eliminate, they're the same, 6 plus 6 is 12. These eliminate, equals 84. Now I know some of you are like freaking out because oh my god, we gotta divide 84 by 12. Good news! They are both even numbers. Let's just reduce the fraction until it's manageable. So they're both even. So 12 divided by 2 is 6. 84 divided by 2 is 42. Now, hopefully you could divide that and get 7. But if you couldn't, you could keep reducing. So 21 and 3. Ooh, that's easy. 7. X equals 7. Never underestimate the power of reducing. So again, I got to go into either the first equation or the second equation to solve for y. I'm going to choose the second equation because no negatives. Try to avoid those negative numbers. 30 minus 14 is 16. Y is 4. I'm kind of out of space, so I'm not going to go show you the check, but I'm going to do it out loud. So my ordered pair is 7, 4. So let's see, 3 times 7 is 21. Minus 24. Oh, that is negative 3, so that works. So you don't always have to write down the check, for those of you who are a little lazy and don't like to write things down. So I'd like you to pause the video and work on number 3. Okay, I'm going to start working on number 3 now, so don't look up if you don't want to see. Because these are already positive and negative, and I'll just make them 20. Uh, 70 and 5. 5 times 10 is 70. 5 times 7 is 35. Add them together, you get... Whoops. That's 50. 85. So we have 16x. If you got the answer 3, negative 2, you did it correctly. Congratulations. What I'd like to do is take a look at the 6 problems we looked at in this video and discuss how you know what to use, elimination or substitution based on the problems. So look at the format of the 3 on this page, and then look at the format of the 3 for substitution. Oh, there it goes. What do you notice is different about the substitution problems? Well, they're not in standard form, that's correct. But what else? One of them starts x equals or y equals. So here's the deal. You have 2 homework worksheets, worksheet 163 and 167 in your packet. If it says solve by substitution or elimination, you can disregard those directions. What I want you to do is solve with the most efficient method. So if you have something that says x equals, it doesn't make sense to solve it with elimination. It makes sense to solve with substitution. That's what it's set up to do, is substitute. If something says y equals or x equals. If everything is in standard form, nice and lined up, you are set up for elimination, combination. Some people would argue that you could take a problem like number 1 and solve for x and y. Well, that's not an untrue statement. It's also not very efficient. Part of being a good mathematician is to use, processes and your tools, strategically. The strategic method here is to look at it and be able to decide, all right, I need to use elimination here based on the structure of my problem. So please make sure you're doing that. Don't just follow the directions or you're going to create a lot more work for yourself. In a second, I'm going to I can turn it anyway because they're puzzles. So here are the answers to tonight's homework. I hope this was a helpful video.